All right, so the 13.2, define general angles and use radian measure. So first of all, we're gonna have a lot of definitions in this one. So angles in standard position, and I'm going to go ahead and draw a little thing over here so we can see what this looks like. And this is going to be 0 degrees, 90 degrees, 180 degrees, and 270 degrees, and then 360 degrees all the way back around over here. Okay, and it would just keep going, but we only need that part for now. So as I write definitions, we'll write stuff in. So first is going to be the initial side, which that is where we can start to form an angle by fixing one side. Okay, so we've got the initial side is going to be here on the x-axis. The initial side. And then we've got I'll try to do it in some different colors. The terminal side. So rotate another ray about the vertex from the initial side. And so that is going to be, doesn't really matter, but we're going to draw it out over here. It's going to be our terminal side. Okay, obviously our vertex is here in the middle. Okay, and then lastly, the definition for this little part here is going to be standard position. And this occurs when the vertex is at the origin and its initial side lies on the positive x-axis. Okay, so the initial side is on the positive x-axis, and then the vertex is at the origin. So this example here would be an example in standard position. Okay, so we'll look at drawing angles with the given measures and stuff like that when we go through examples. So then another set of definitions here, or another definition. I like doing different colors, so let's just keep mixing it up. Coterminal angles. So I'm just trying to move the thing, but I guess it's not going to let me move it, so let's do it this way. Coterminal angles, their terminal side or terminal sides coincide, okay, meaning they're the same, okay, or they overlap at the same place or whatever. These angles are ones that are found by adding or subtracting multiples of 360, or 360 degrees, I should say. So, for example, a coterminal angle with (140 degrees) is 500 degrees because 500 minus 140 is equal to, I don't know why I just did, hold on, ignore that. That was obviously not right math, and you probably realized that. 500 minus 140 is 360, so those are coterminal angles. So a lot of times these will ask for one positive and one negative angle that is coterminal with the said angle. All right, so another little like topic here. Let's go with bright purple. Radians. So you've probably heard me mention that a couple times, that word, in different stuff recently. But this is just another way to measure angles like degrees, okay? It's a measure of the angle in standard position whose terminal side intercepts the arc length r. Okay, so wish I had a tool that would like draw me a nice shape, but I don't think I do. Probably not. So anyways, I'm just gonna attempt to draw a circle here. Don't judge my circle. It's not too bad. So we've got one here and we've got another value here. Okay, so these are the little r's that are your radius basically. And then out here, if we were to extend it, this value out here is another type of r. It's your arc length r. Okay, and this value in here is 1 radian. Okay, so some facts about this. There are 2 pi radians in a full circle. 360 degrees is equal to 2 pi radians. And 180 degrees is equal to pi radians. Okay, and there's just a couple more things. So I know this video is a little long, but I just want to go ahead and get through it. Converting between degrees and radians. So a lot of times you'll have a problem that'll say, what is, if the problem is given in degrees, it'll say, what is it in radians, and vice versa. So what does that look like here? So if we are to go degrees to radians, so if you're given degrees and you want radians, we multiply degree measure by pi radians over 180 degrees. And if we are to go radians to degrees, we multiply radian measure by 180 degrees over pi radians. Okay, so we'll set these up a lot like conversion charts. And one other thing to make note of, okay, I won't accept this any other way. Leave your answers with pi as part of it. Okay, so for example, 3 pi over 4. Okay, don't multiply the pi through. Okay. And again, there's one more thing we'll have to go over with this section. But the last little bit of notes here. Okay, is going to be about arc length and area of a sector. Wow, that looks awful. Start over. So the definition for this, a sector is a region of a circle that is bounded by 2 radii and an arc of the circle. Another definition, a central angle theta of a sector is the angle formed by the 2 radii That color is like almost identical to the one I've been using, isn't it? Just make it more periwinkle. The arc length S and the area A of a sector with radius r and central angle theta. Okay, and that will always be measured in radians. Okay, if it's not in radians, it won't work. They are deals with that. Arc length S is equal to r theta, and area A is equal to 1/2 r squared theta, or 1/2 rs. Okay, so whatever I'm trying to do isn't working, so we'll just go back to this. So I have a circle here. I'm going to break it up into a section here, and then okay, that didn't work like I thought it was going to. I'm going to color this little area in here. Okay, so this area, and then I'm going to have the angle theta, which is the central angle. Then this area in blue is the sector. And then this area here in green is the arc length, S. Okay, and these are R's here. Okay, so we'll have to find the arc length and area of a sector given all of this information. So I know it's a lot of notes, and I'm sorry it's so long, but I just need to get through this so we can spend time doing plenty of examples in class.